Preparation of salts. This will give you an overview for preparation of salts. Okay, it is not very detailed, it's just an overview, but hopefully it helps to build on your understanding and gives you a better summary of the entire topic. Okay, there are many different ways in which we have learned from the previous topics on how we can produce salt. Okay, previously for you, maybe if I give you, I want to prepare this salt, let's say sodium chloride, okay, you can suggest sodium plus. Okay, I can use sodium metal plus acid, hydrochloric acid, and I know that I can get sodium chloride. Okay, but after this topic, you realize that it is not suitable to use sodium metal, okay, to react with hydrochloric acid, okay, because of certain restrictions. Okay, so for this topic, please focus on the property of salts and also the methods of salts to determine which reactants to use. Okay, so I repeat again. Number one, you should look at the solubility of the salts, and then number two, okay, you need to decide which method to use, and then from each method there will be specific reactants that is required to make the salt. Okay, so first thing, let's try to recall the solubility of the salts. Okay, it may seem that intimidating to memorize it, okay, but it's actually quite simple. Okay, all nitrates are soluble. Okay, for sulfates and chlorides, you have to pay a little bit more attention to them. Okay, so I will teach you the way how I remember it. Okay, so I'll remember Bochap-Del, BCl, or it can be anything that you can make a short form for to help yourself to remember. So BCl, Bochap-Del, barium sulfate, calcium sulfate, and lead 2 sulfate are insoluble. For chlorides, you can choose to remember SL, CL, or student leaders, sports leaders, whichever that you prefer. Can be silver chloride and lead 2 chloride. Okay. Then for carbonates, all most of them are insoluble except for SPA. SPA stands for sodium, potassium, and ammonium carbonate. Okay. In fact, as long as it's a SPA compound, okay, it will be soluble. Finally, for oxides and hydroxides, most of them are insoluble except for group 1 oxides and group 1 hydroxides. Okay, now I'm going to show you this very important flowchart which will help you to determine what method should I be using. Okay, so first of all, you must always establish which method. Then from there, you will know what reactants to suggest. Okay, I'm going to try to explain the reactants later on why we need to use a certain reactant. Okay, so first question you need to ask yourself, is the salt soluble? Okay, if it is, you have to ask yourself another question, is it a SPA salt? Okay, SPA represents sodium, potassium, and ammonium. Okay, so if it's not a SPA salt, which means that it's like magnesium chloride, or it could be calcium nitrate, okay, then you can use this method, which is known as the reaction of acid plus excess insoluble substance. Okay, the word excess is very important for this method, which I will talk a little bit more about it. Okay, if it is a SPA salt, okay, very straightforward. As long as it's sodium, potassium, ammonium salt, you will use titration. Okay, and you should know that SPA salts are all soluble. Okay, finally, if the salt is not soluble, okay, we will use this method called precipitation. Okay, now we are going to look more in depth into the reactants and also try to recall the various steps to prepare them. Okay, so first of all, for the acid reaction, okay, you need to pay attention to the anion. So if you see that it's chloride, okay, you will need to use hydrochloric acid, sulfate, sulfuric acid, and nitrate to nitric acid. Okay, so now I'm going to show you one example of acid reaction first. Okay, so now I'm going to prepare copper 2 sulfate. Okay, so copper 2 sulfate, okay, you should be able to recall that I need to use acid reaction because number one, it is soluble. Okay, number two, it is a non-SPA salt. Okay, and based on this method, okay, I know that I need to use acid plus an insoluble reactant. Okay, insoluble reactant. Okay, so let's take a look at why must we make sure that the insoluble reactant in this case, which is copper 2 carbonate, must be in excess. Okay, let's take a look at why is that so. Okay, when you first start the reaction, you will notice that okay, there are quite a lot of things, okay, and it is not easy to actually remove the other reactants. Okay, so if you pay attention, okay, when I want to do this reaction, okay, I also need to make sure that I only obtain my pure copper 2 sulfate. Okay, so what I can do is that if I keep this in excess, okay, I can ensure that all the acid has been reacted. Okay, so this means that the purpose of making sure the excess, if the insoluble reactant is in excess, is to make sure that all my acid it is completely used up in the reaction. Okay, why is that so? Why do I not want to make sure that the acid is in excess instead? Okay, because pay attention to the state symbols. Okay, for the acid, okay, it's aqueous. Okay, the copper 2 sulfate is also aqueous. Okay, if you have two soluble substances together, it'll be actually more challenging to remove them. Okay, so therefore we choose to actually make sure that the insoluble substance is in excess so that I can do filtration to remove it later on. Okay, so the purpose of step 1 is to add the insoluble copper 2 carbonate in excess to ensure that all acid has been reacted. So my first step, I will have the following substances that is being formed. Okay, but carbon dioxide, you don't have to worry about it because it is a gas, it will just escape. Okay, so right now let's take a look first. Okay, sorry, there's an error here. This is H2O, okay, which is liquid. Okay, so right now you can see that we have our copper 2 carbonate present with my copper 2 sulfate, water, and carbon dioxide gas. Okay, so the next step, naturally, I need to filter the mixture. Okay, the purpose of filtering is to make sure that I remove the insoluble copper 2 carbonate, okay, which will be stuck as a residue, and to make sure that I collect my copper 2 sulfate solution. Okay, so step 2 will enable me to only have copper 2 sulfate solution left. Okay, so in order to remove the water, okay, I try to heat it up until it is saturated. Okay, so once it's saturated, I'll start to do my crystallization. So crystallization will need to undergo cooling to let the crystals form. And then after you actually undergo crystallization, you will know that you need to filter the mixture one more time because there might be some water left. Okay, then wash the copper 2 sulfate crystals with cold distilled water. Okay, it is important that we use cold distilled water because you know that the solubility, okay, of you know that under cold temperatures, right, the solubility will not be so will not the salt will not be so soluble. Okay, because copper 2 sulfate is actually a soluble salt. So in order to make sure that you don't dissolve the salt, you just want to remove the impurities, you need to make sure you use cold distilled water and you dry it using 2 pieces of filter paper. Okay, so I hope that you understand why the insoluble reactant is in excess. Okay, so for acid reaction, we either use acid, okay, plus metal, or we can use acid plus metal hydroxide, metal oxide, acid plus metal carbonate. Okay, so that's why this is the suggested reactants. Okay, but please take note of 3 special cases of these metals. Okay, these metals are copper, silver, and gold. They do not react directly with acid because they are very unreactive metals. Okay, so later on in the towards the end of the year, you will learn about reactivity series of metal, and you will know that these 3 metals are very unreactive, so they cannot react with acid directly. Hence, you can use either copper carbonate, copper 2 carbonate, or you can use copper 2 oxide to react with the acid to produce the copper salt that you want. Okay. Okay, now I'm going to move on to titration. Okay, for titration, I will need actually 2 soluble reactants. Okay, I will need to use acid plus either a metal hydroxide or metal carbonate. Okay, many times students will think that why can't I just use sodium to react with acid directly and then I can do my filtration, it'll be much easier. Okay, the reason is because sodium potassium metals are very reactive. Okay, so if they were to react with the acid directly, the reaction will be very explosive and it will not be feasible to be conducted in the lab. Okay, so for titration, okay, it will be slightly more challenging.